Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining Ethernet. Now, when we talk about the data link layer and layer 2 implementations, the dominant technology that lives there is Ethernet. There are others, of course, but virtually all network switches today leverage some form of Ethernet. In this lesson, we'll talk about this technology, how it has become an inseparable part of networking, and switching in particular. You can't know about networking unless you are very familiar with Ethernet. So let's get started. Ethernet was born way back on May 22, 1973, when two computers were connected to each other with a coaxial cable, and they began exchanging data at a bit rate of 2.94 megabits per second. It was first named Ethernet back then by one of its developers. Since then, Ethernet was adopted in the early 1980s into the Institute of Electrical and Electronic Engineers, or IEEE, standards, defined as IEEE 802.3. If you've been around networks, this code should sound familiar. Over the decades, Ethernet has evolved tremendously to what we have today, and it continues to be developed further. So learning the fundamentals of Ethernet is crucial to your understanding of networking. At the very center of Ethernet is the Ethernet frame. By learning about the frame, its header, and the fields found within it, it helps to give us a clearer understanding of how switches function and operate in our networks. Here is an Ethernet frame. The frame is a result of the encapsulation of the IP packet, which is the entity or the protocol data unit used in the network layer, or layer 3. That becomes the payload of the frame. During this encapsulation, the Ethernet frame header is added as well as a frame trailer. It's quite a simple header which includes three primary fields: the destination MAC address, the source MAC address, and an EtherType identifier, which is used for one of two things, depending on its value. Either as an identifier of the protocol contained in the network layer, that is, it identifies the IPv4 or IPv6 protocol in layer 3, or it's used as a length field indicating the size of the payload in octets or bytes. I won't go into these details here. I will explain the EtherType field in detail in an upcoming video. We also have a preamble and a start of frame delimiter, or the SFD. Now, these here are not strictly part of the Ethernet header, but they are used to help network devices understand where the previous frame ends and where the new one begins. All 7 bytes or 56 bits of the preamble alternate between ones and zeros, and it's also used in this sense to help receivers synchronize their clocks with those of the transmitters at the bit level. The start of frame delimiter, as its name suggests, indicates the start of the frame so that the receiving device begins to interpret the very next bits as part of the frame header. Finally, we have a frame trailer added at the end as well. Now, unlike upper layer operations, Ethernet adds this frame check sequence at the end, which is a cyclic redundancy check, or CRC check, on the rest of the frame. This error detection process essentially takes the bit stream of the frame and computes a value that it stores in the 4-byte FCS. This value is computed as a function of all of the bits in the Ethernet frame fields except for the FCS field itself. The result is stored in the FCS field as the frame is being sent. Once the receiver receives it, the same algorithm is used to compute the value, and it's compared to the value in that field. If it's different, the frame is considered corrupted and dropped. If it's the same, all is well and the frame is processed normally. This is essentially an error detection mechanism, which eliminates frames that may have been corrupted by physical layer phenomena. It simply detects errors. It leaves the error correction mechanisms to higher layers in the OSI model. Now let's take a closer look at the actual frame header. Specifically, we'll be looking at the source and destination MAC addresses. These are 48-bit values that represent the physical address of the communicating devices. These are typically written out in hexadecimal for us humans to read, but on the devices themselves, they're represented in binary. MAC addresses are hardwired into the devices themselves. From the factory itself, they are assigned these values, and there's a specific method that's used to assign these values to ensure that there are no duplicate values on any single network. A typical MAC address looks like this. We'll go into more detail concerning these addresses in upcoming videos, but for now, I can tell you that all network devices have this hardwired physical address assigned to be used for layer 2 Ethernet communication. All network devices have them, including your PC, your laptop, your IP camera, your printer, your wireless access point, and any other device that connects to an Ethernet switch. These are also assigned to wireless devices that use Wi-Fi as well, but that's a whole different chapter. The idea here is that these MAC addresses are unique on a network segment, and they uniquely identify any connected network device on a segment. This allows layer 2 connectivity and functionality on all connected devices. As we have seen in previous videos, and we will dive deeper in upcoming videos, these MAC addresses play the primary role of operation for layer 2 switching, and they are also involved in how Ethernet works on the data link layer. Now, one more thing I'd like to share with you before I go. The frame header can also have an additional optional field called the VLAN Tag. This is defined by the IEEE 802.1Q standard. This field is inserted between the source MAC and the EtherType fields. The field contains VLAN ID tags as well as quality of service information, all of which are used on trunk links between switches. If you've heard about VLANs and QoS, this is where they live, at least as far as the communication between switches go, and at least as far as layer 2 is involved. So that, my friends, is an overview of Ethernet and the structure of the Ethernet frame. A very fundamental and crucial part of understanding layer 2 and switching in networks. If you've watched to this point of the video, then you're probably one of my more faithful followers, and I really do appreciate that. I'd just like to share with you about my recent publishing of content on my website at www.telecomtech.io, where you can find more in-depth courses on networking topics with labs, quizzes, exams, and in-depth configurations. I don't yet have very many courses available, but more are coming soon. So check it out, subscribe to my newsletter, and get better deals on the courses I publish. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.